Hey, good morning, everybody, fellow vExperts out there. Thanks for joining us this morning. We've woken Rollinson specifically up out of bed just for this briefing, and he and Josh and myself and others are raring to get into the topic of VRealize Automation. And so with that, what we'd like to do is get an introduction of our presenters today. My background, I should say, is business development within SolidFire. That means that I work with VMware in a specific way to help us advance our integration and help advance technical solutions. With me, I've got Josh and Rollinson. I'll have them introduce themselves as well. Josh?
Good morning, everybody. Josh Atwell here, Cloud Architect for SolidFire. My primary focus is on automation integrations within the VMware ecosystem and beyond that. And really excited to have an opportunity to talk with you guys about some of the work that we've been doing with Rollinson and with VMware around enabling storage automation.
And of course, Rollinson might not need any introduction, but go ahead, Rollinson.
My name is Rollinson. I'm one of the members of the Storage and Availability Business Unit at VMware. Obviously, I work on a lot of the storage solutions, and I tend to obviously sometimes poke my nose where it doesn't belong, such as VRealize Automation, and try to make things work for the software-defined storage strategy and make everybody work consuming our control and data plane.
Excellent. Thank you, Josh and Rollinson, for those intros. Again, just to reaffirm, if you have any questions, ask those in the chat window, and then afterwards we'll try to open up the lines. I think if we can, we'll try to open up the lines and ask more specific follow-on questions at that time as well. Also, lastly, the hashtag, if you want to be tweeting a few things, it's the hashtag is fueled by SF, as in solid fire. So that's fueled by SF. With that, the agenda, what we want to cover this morning, is really all about trying to solve for the problems that IT consumers have with the last missing link, storage, or one of the last missing links in storage. We'll specifically go through some of the enabling technologies, and this is where we're going to spend a good chunk of our time on things like SPBM, also known as Storage Policy-Based Management, the VMware VASA providers, and some of the generations of the VASA providers, VRealize Orchestration, which is one of the key components to making VRealize Automation work and function in specific ways. Those speak to some core functionalities that we'll see later in demos work. We'll give you a quick SolidFire overview to give you a context for who we are and what we're providing as an underpinning technology to expose specific capabilities up to a service catalog and application move, add, change scenario. And then we'll get into a tech preview, a demo of the VRealize Automation service catalog we built and some of the things that are related to the specific feature sets exposed for move, add, and change to specific application builds. We'll also get into some deep dives into the integration, kind of how did this all come together, what are the details behind the scenes. And then we'll kind of tease you a little bit with the futures of what we're working on together. These are things like vVols, the VRealize Orchestration plugin, and a few other things that are next. So, jumping right into things, the first section we want to cover was IT consumers and the problems that they have with storage. In this case, if you look at consumers and what they currently receive, it is basically a construction of silos in enterprises. These are where we have static classes of services, rigid provisioning. What we want to have is better controls, but ultimately what you end up seeing is frequent data migrations as people live through generations of storage architectures. This creates a whole bunch of problems where storage policies may not be as dynamic as you'd like, and you find them a little more static in their capabilities. Ultimately, you don't really have a great way to deliver guarantees of performance. About the best we can do is rate limit and do some things that are somewhat effective but not ultimately effective in guaranteeing the performance. Ultimately, you have other tenants that risk the impact of those consumers on other applications. And ultimately, you end up with a scenario where all virtual disks are created the same. And we all know that not all things are equal in a virtual infrastructure. as all of you live through in your administrative and vExpert daily walks. And ultimately, what ends up happening is the operating costs end up gravitating towards the higher performing requirements of the VMs that need infrastructure. So you really have a lack of efficiency in what you try to put together for VM designs based on some of those inabilities. Rollinson or Josh, anything else you guys want to add here?
Well, yeah. So obviously, I think today a lot of the focus on the way storage is managed is very, as you stated, done in silos. So we tend to manage and consume and design storage infrastructures based on these precious metals. In today's world, there's one terminology that I keep hearing over and over again, which is, people want agility. People want agility. Infrastructure needs to be agile and be able to do all these things. And obviously, with the demand of really large infrastructure, cloud infrastructures, where the demand from applications requires such dynamic behavior and ways of not just consuming it, but also having to manage it in an infrastructure like that becomes very challenging to sustain it in the way that we typically do it, which is why some of the advancements that have been applied now in the new software-defined storage strategies from the different vendors that we have. It's what we're trying to alleviate, the problems that we're trying to fix is exactly that. Be able to deliver something that it's a bit more dynamic, but also have more control. The term agility without control is something that I've been kind of professing since VMworld last year, and we have valid points and proof that this is what currently happens, and where some of the big pain points we're trying to correct here with some of the things that we're doing now.
Yeah, and I'd like to also add that one of the things that excites me the most about the work that we're doing with VRealize Automation and with SolidFire isn't just about provisioning. It's really about enabling consumers throughout the entire life cycle. So, as you'll see in the upcoming slides, the focus was beyond just, hey, I can provision a new virtual machine with more control and agility. It's more enabling consumers throughout the life cycle of that application and that virtual machine. So, and I think that's something that a lot of organizations and especially a lot of consumers have been they've been wanting for a long time.
So the consumers ultimately, what they're looking for, and this is not news to anybody, they're ultimately looking for, I think, what you really wanted in the first generations of starting the virtualization journey and virtualizing Tier 1 apps. They all want it to work together with the specific precious metal policies, the ability to kind of match up needs to what you can justify from a budget perspective, as well as an ability to be able to have that be kind of on the fly, flexible, and something that's adaptive to controls and to change, because that's the name of the game. And as a result of that, one of the things that we end up seeing is that not all virtual disks are equal. This is a blinding statement of the obvious, and this is the same whether you're talking about SolidFire or anybody else. The core tenet here is that as you look at the characteristics and the needs, whether it be from an I/O profile or other things that you would tend to design for, not all of those requirements are the same. And when you do the virtual designs that you all do out in the vExpert Walk of Life that you guys have, that's, I think, where you start to, I guess, not just require, but really desire something that will give you finer grained controls. And here, we're breaking apart more granular controls that talk to the basic performance needs of an OS versus an app versus a database. And we start to introduce characteristics, things that you could get, things like min, max, and burst type of settings on those core I/O characteristics. Rollinson or Josh, want to add anything? So ultimately, the full evolution you end up with is, really looking through where we start today with silos, and this is pretty evident when you look in your data center and you see, types of different storage arrays in the environment that have served different needs over the course of time. As Steve Herod once said, it's sort of the museum of IT decisions past and the ultimate legacy of IT buying history. And we've done so for specific needs and for specific silos. So as we move that to the true consolidation we've tried to do through the history of virtualization, what we end up wanting and looking for is granular controls. All right, let's get into the enabling technologies and talk more specifically about SPBM, VASA, vSphere tags, VRealize orchestration and automation, and just what are the underpinning technologies. And from there, Josh, take it away.
Actually, I'm going to let Rawlinson jump on some of the VMware specific stuff around the first couple of slides.
Thanks, Josh. So obviously today, with the new storage sort of shift that's kind of taking place, more the software-defined approach, there are a couple of technologies that come into play, particularly for VMware. The policy-based management framework is key, and it's huge to what's happening here. So obviously, what's we enable now in the new framework is the fact that we have the ability through the new VASA version that provided the new VASA APIs, the new version. We enable a two-way communication between the array, but also the sphere itself. And what comes out of that is the fact that a storage subsystem is able to expose capabilities. So whatever data services a particular storage device is able to have license available, that it can be consumed on a per volume level, on a per LUN level, whichever construct we want to call it, so that we can now effectively consume it on a per object or per VMDK basis, depending on how the system behaves, whether that could be whether it utilizes virtual volumes, whether it utilizes an individual LUN or an individual type of object approach. But the way in which these capabilities are translated and consumed into the vSphere platform is in the way of what we call VM storage policies. So now we have the ability of putting together a set of storage capabilities, snapshot, as you see them here in the slide, replication, duplication, whatever that may be, and put them together into a form of a policy which can then be applied onto an individual object of a virtual machine or a service level that could be offered by a particular LUN, right, or a particular volume per se. That is then now consumed into vSphere, where now the agility with more control that everyone's been asking for or talking about can actually be achieved, because now the platform itself is able to sustain and maintain a compliant way to identify whether or not these capabilities are currently being applied to any individual VM or their VMDKs based on that policy that's been applied to the object or the volume itself, which is really key and important, because if you think about how we normally do this, without this sort of framework, it's manual, right? And the point that Keith and Josh were making before about, in the traditional way, the silos, we require to do a lot of movement of data. And necessarily when it comes to moving data, there's a lot of risks that are involved when doing such things, because as humans, we can make mistakes. We can choose the wrong data store. We may not do all the validation to understand whether there's enough capacity that can really satisfy what it needs. Well, this new framework and capability, because of this two-way communication, is able to systematically identify those values. And when it's not, then obviously it triggers a non-compliant, and then an operation is triggered from that. So it's very, very important to understand how these two things become together from a storage perspective, as well as they're going to be combined into a VM storage policy, and which actually is what makes the whole framework work, not just with the new software-defined storage technology, but also it offers the ability to move towards that management model much more, I would say, a bit faster than it would be to a traditional change with such a dramatic change that is just introduced. So one of the things that you can see, for example, is, and this is just one of the examples that that could be potentially exposed, depending on the capabilities and service levels that are exposed from a particular vendor. Here you can see how, from a SolidFire perspective, you can see how one of the few vendors, and I can say this because I know, that offers this IOP guarantee. So basically, you can see how one of the capabilities that are exposed as a policy is one of the very same service levels that SolidFire offers, which is the ability to give you TOS. Now they're doing it here in the implementation, which we're looking at it, which could be applied on a VM basis, but also more effectively on a per VMDK basis, right? So these are sort of the things that you can see available that are exposed as a storage capability, which are then consumed as a policy framework, which will be added on a per VM basis. You don't have to have all of these things set up. You can selectively choose what you want depending on what an application really needs. And you can see that based on this, we're sort of can sustain and apply these requirements per se throughout the life cycle of a potential virtual machine or virtual disk, which is very powerful from a management, operation, consuming, upgrading capabilities, because these things will be maintained throughout the life cycle of any given virtual machine and its objects, right? And it's very powerful to be able to do these kind of things. So one example here that you can see, and you know, I get the opportunity to work with Keith and Josh on a particular project here. Here's an example on how you can identify how vSphere interprets what's going on in a particular array. In this case, we have here 3 different types of offerings in the form of a policy. Now, what we're trying to achieve here is, instead of what we normally do as an operation, as a vSphere admin, where we have a virtual machine which is composed of multiple disks, we either create a template that has the pre-built settings in such ways where the things are already mapped, or we can default to a policy approach where, based on the requirements of each individual disk, that's one of the things that Keith said, which is so true, not every virtual disk is created equal. They may have different requirements. Your storage subsystem may be able to offer different performance capability, different availability requirements, different recoverability requirements and such. In this particular case, we're looking at very specific guaranteed performance, right? But now you can see that on a per object basis, you may not want to have the same requirements from a performance standpoint on your base operating system disk than what, for example, your database disk will end up needing. So being able to selectively choose on a policy basis, on a policy model, the actual requirements to guarantee a service level agreement on a per object, per application basis is very powerful, not only from a value perspective, but if you think about as storage admins, as admins that we were at some point or we're still dealing with, or as an architect when you have to define and design solutions to support such behavior, the amount of effort that it takes to do this, right? And now we're actually still putting this back up to a more of a systematic approach where now we're offloading these things, reducing the risks, and making sure that service levels are guaranteed, because the system tracks compliance. And you can see that here in the screenshot where you can see the compliance based on a time that is continuously checked to validate whether or not those service levels that you are trying to provide for that application are being satisfied at all times. So moving on.
Yeah, Rollinson, one of the things I'd like to just point out here that I think is just for background, when people see Mongo standard and performance, and this will be covered a little bit more in the technology underpinnings, we basically had on staff we've got some specific database experts, and they gave us some presets here for Rollinson and Josh to construct up some pre-made min, max, and burst settings. So in this case, like a MongoDB setting for maybe a classic MongoDB build, they set a policy and a standard up around 3,000, 8,000, and 15,000 IOPS as the min, max, and burst for Mongo. So if you have that selected, then that's what you're going to get for performance. And what's interesting is that if you check the compliance, compliance, is a funny thing, because you might be good today, but the question is in the future, as you have other things that interfere with performance, the question always is how do you try to ensure that compliance over time. So just a couple quick background points there.
Sweet, Keith. So obviously, when we talk about this, we introduced the storage policy-based management framework in vSphere 5.5, right? And now we're on to vSphere 6.0. So there's a couple of things that have now been introduced to enhance VMware's approach on this control plane and the data plane they've introduced with the software-defined storage strategy. So let's talk about a little bit on what's new, what's being introduced here at this point. So by now, obviously, the way some of these capabilities and some of these things are happening is via a VASA provider for a particular technology implementation. So whenever we hear the term of a VASA provider, for VMware specifically, it comes in two ways and two forms. So there's a VASA implementation for one of the storage products that VMware today delivers, which is called Virtual SAN. The other one, which is our ecosystem, everyone can now share the same sort of control plane, data plane, and values delivered in the software-defined storage strategy, is virtual volumes, right? So with virtual volumes, the VASA provider is the thing that is responsible for communicating between the storage subsystem as well as the vSphere infrastructure. Now, that is just one of the components of that solution. But if you look at how important it is and what it actually does, it actually explains how things are taking place and how the communication between the actual array and vSphere takes place today. So, for example, when we first initially released the VASA 1.0, VASA 1.0 was able to expose storage-based capabilities up to vSphere, so we can actually go through our I forget exactly what we call that feature initially, which is something profile. I'm sorry for I'm kind of blanking out.
If we go to the next slide, we've got there you go.
Oh yeah, okay. So I'll touch on that. Yeah, good. So let's just go back to that one, to the other slide real quick then. So when you look at the components and the type of communication that takes place here, now you can very clearly see here how this is a two-way communication. So particularly when it comes to the virtual volumes world, understand that now the communication arranged between vSphere and the storage subsystem is arranged between the vendor of your particular array. So in this particular case, SolidFire is able to develop the VASA provider, which is the API calls that communicates and translates all the communication, all the actual actions that are happening between the array and vSphere. Right? So now we actually have the ability to offload these operations down to the array, where now the array can effectively manage and assign these policies that I talked about before based on its capabilities. Right? So this is how this obviously is implemented. Now, when it comes to virtual volumes, it's just something that you have to have a virtual volumes capable array, which may require a firmware upgrade to get to the point where it understands that. But also that's something that will be available from the different vendors. Obviously, SolidFire is one of the partners in the virtual volume project, and that's something that they're doing. But they are entirely in charge of developing this VASA provider, which could be implemented in one or two ways, which could be a virtual appliance, or it could be residing actually directly on the array itself. That is an implementation detail that your vendor chooses to use based on how the architecture works. Overall, the VASA provider is what actually handles and manages the communication between these two frameworks per se, vSphere as well as the storage subsystem, and it's able to consume and place the objects or the VMDKs that we're using and assigning those policies individually on the array itself. So there's a lot more to the whole virtual volume piece, but you can see here the evolution between the VASA and what's going on between the different eras or the different versions, where the communication that's taking place now, which is the point here, is now more effective and more it delivers a much better service than it did before, because now we've evolved. We're trying to fix a problem which goes beyond just knowing what the storage subsystem is able to deliver today. Next slide. And here, I think Josh can actually, we talked about, you can comment on this, and I think just to the point that I forgot before, when we initially introduced SPBM, which was the initial introduction to it was with VASA 1.0, was with vSphere 5, the feature 1.0 was called storage profiles or something like that, I think it was. I'm sorry that I keep blanking out on this. But the way this was leveraged was, one-way sort of communication, which you can see what the storage system can give you. We have a lot of different capabilities that are exposed in such ways. But then it comes a question about how do we manage, or how does this behave with the rest of the vSphere or the rest of the enterprise capabilities that your storage subsystem is able to leverage today in terms of storage DRS, whether we deliver IO stats, events, and alarms, and all these different things. So in 1.0, there were obviously certain capabilities that we'll leverage, including the tags versus a dynamic approach where you can selectively choose what these capabilities are without having to individually add a vSphere tag to the different services or different runs or volumes that you may want. I want to make this perfectly clear. That is not a bad thing because tags are very powerful and very useful. And you'll see here in a little bit how we actually were able to combine all the different storage technologies that are supported within vSphere, whether it's an external, internal, virtual volumes, NFS, or VMFS, all together while leveraging all of these different capabilities in one, right? Obviously, the new iteration of the VASA 2 provider with vSphere 6 enables, a vVol type of profile capability. It delivers a much more efficient management approach to the different VMs and objects with capabilities and features such as we can automatically now, within virtual volumes, do an unmap call to reclaim storage spaces, right? But that obviously depends, again, whether it's an implementation of your storage vendor, whether that's leveraged to kind of take advantage of these capabilities that are now more efficient as we evolve and try to fix and address other problems with different technologies that are implemented. VMFS with virtual volumes, different capabilities work. It's still the same VASA provider is able to deliver its value depending on the type of implementation you're doing, whether it's going to be VMFS or virtual volumes. Either way, you can see the benefits here. But the point you get out of this is how we're fixing problems beyond the technology. Because for me, what's really important is more of the overall operational efficiency and consumption of an infrastructure as well as managing it. And a lot of it is more than just the individual technology bits and pieces that are exposed. They're still important, but what problem are they really fixing? When you look at, for example, now what we do in this sort of paradigm shift, if we go to the next slide here.
Hey, Rollinson, hold on a second. I think Josh is going to add something.
Josh, yeah.
Yeah, one thing I wanted to add on to that is that these technologies having been in place for a little while and exposing, one thing that's really exciting, especially from a standpoint of what is capable within an automation scope and an agile granular control scope, is that with VASA version 1, all that a storage vendor like SolidFire is really able to provide up is simply a key value pair, right? We provide in our capability profile an opportunity to say that this tag, or what this is supposed to be, it's from a storage perspective, is just a single string, right? So with a traditional storage platform, you would look at that one that's presented as a data store would come out, and the storage administrator would essentially identify that as one of your precious metal policies. It's going to be gold, silver, bronze, based on how they identified capacity, how they identified the performance, what the characteristics of the underlying hardware was. And it was fairly limiting. With SolidFire, given that limitation, we work to present up through the VASA capability profile a string that essentially provides the QoS profile, so that when you build storage policies off of that capability profile, you're reading that in and identifying that that storage policy aligns with this capability profile that was reported to ensure that maintains consistent. What that allows you to do, that's a big step away from tags. It allows you to be much more dynamic going forward, which is really important moving forward with a vVols implementation, where you're not doing VMFS data storage, you're doing vVols volumes. And when you do that, the VASA provider is able to report up essentially a metatable, right? As a storage provider, you identify the metatable of the information that you want to present up, and you have a much wider range of key value pairs that can be presented up to identify the capabilities of the volume being used. A great example of that was in a previous slide. I'll see if I can pull it up here in a second. You may recall when we were talking about the fact that we can present minimum, maximum, and burst IOPS. We can do those as individual calls, right? It doesn't have to be in a single string. We're also able to report up whether or not that array is encrypted, whether or not that volume has replication applied to it. We can also identify whether that volume has snapshots applied. These are all different pieces of information that we are now able to take advantage of with the next generation VASA provider and next generation SPBM. So that evolution moving into vVols is going to start enabling a much broader, much more granular amount of control that kind of hits to the heart of what we've been talking about here. And it's been really exciting, at least especially from my standpoint, with the capabilities that are being exposed.
Totally. Couldn't agree with you more, Josh. But here's another topic where we're finding, I particularly myself, and I'm sure you guys out there have as well, there's this ongoing conversation about, responsibilities, job roles and things taken over in certain ways. It's important to understand that we are really introducing now a change in more than just technology. And like I said before, for me, it's not just the technology. I'm a very operationally focused person. So it's important to understand that while we're delivering a technology improvement, and obviously as things change, we're also delivering a much better way for the individual parties that are involved in managing an infrastructure, particularly now here with vSphere and a storage admin. It's not always per se that one is taking over another's role, but you got to look at it in a way as it's increasing manageability of an infrastructure so that it's consumed more effectively. So in this particular example here, when we look at the management workflow that, for example, is being introduced for virtual volumes, it's relatively different in a way that some of the things we do today. And let me explain here why and how it's typically done. So as storage admins, we typically are in control. When you talk to any infrastructure, to anybody else, a storage admin, a storage architect, will look at the vSphere admins as their kid, per se, and treads the waters very carefully when he unleashes and gives them powers and things to do. Because if there's anyone that's concerned and worried about not only having an outage, but potentially putting a company out of business, is a storage person, because that's where all the data resides, and that's they're responsible for. So they tread those waters very carefully. So when it comes to being able to deliver effectiveness in a way of becoming, delivering that agility, but more efficiency overall, look at how the things that are introduced for virtual volumes per se. So here we have, number one, we can deliver a much more efficient or more cohesive, a better communication between the two, while offloading some of the tedious tasks that happen depending on the size of the infrastructure from a storage admin perspective. So in a typical world today that is, for example, utilizing virtual volumes, this is what's coming, folks. It's released. This is what everyone is trying to actually get to right now. A storage admin has the ability to create a construct within a storage subsystem that is identified now as a storage container. A storage container, I don't want to get into details of that virtual volume stuff because it's not what this is about, but I just kind of want to give you the high-level kind of view on this. So the storage container is the construct on a storage array that lets you, it's utilized to store virtual volumes, right? And it lets you allocate a space and define capabilities like the ones that Josh explained here, particularly, in this case, applicable to SolidFire. So why do we do that? So here's one of the things. So that's what the storage admin can do. Once the storage admin creates a storage container with X amount of capabilities, with X amount of capacity, a vSphere admin can now map a virtual data store to that particular container. The thing here that's different is that a storage container, a storage admin is able to enable capabilities on a per container basis. So in today's world, what does that eliminate? The precious metal approach, right? Because we normally, what we would do is that we define different runs in different volumes that were capable of doing different things. One will do the replication, one will give you QoS, the other one will give you snapshotting capability, the other one will give you high availability. So that is more things to manage, more things to touch, more things to deal with, and it introduces more risk up to the vSphere stack because now we see multiple runs that we have to have a vSphere admin that can choose them. And let's be honest here, the risk there is the fact that we're humans, and sometimes either Doug may be working around with some things that he shouldn't be working around with and looks the wrong way, and selects the wrong run and puts the VM where it doesn't need to be, right? That's a risk. That happens. A lot of different options. So here, we have the ability now where a vSphere admin can map a particular data store to a specific storage container. That container has all the different data services that a storage admin has safely decided to expose to the vSphere admin, so that he doesn't have to go back and call and say, listen, I need 3 LUNs that can give me this kind of capability. They need to be a design architected, and we have to make plans for that individually. When now, the storage admin can do that from one specific storage container. See the power here? See the value is not just about on the technology that's being introduced, but on the effectiveness of this new operational model and the management workflow. So moving on from that, you look at, because the storage admin has access to the storage capabilities, right, he's able to do that. Well, how does that translate to vSphere? Those storage capabilities, once they're exposed to that container, the vSphere admin can now consume them and access them via storage policy. So the vSphere admin can choose from a list, from a menu per se, and say, you know, what are the capabilities that are being exposed here? Do I need to create a policy for this particular application? Whether it's a database application, whether it's whatever, regardless of what it is, you build the requirements from a storage perspective based on a policy and apply them individually per object. Think about how powerful that is. So once the virtual machines are deployed, they have their policy on the storage side, on that container. A storage admin will recognize what each individual one of those disks are, because they're going to be represented in the form of a virtual volume. Now, they can track the performance. They can now look at those individual objects and understand what the translation or what the correlation is between a particular virtual machine and a particular object. So it's not that we're removing the responsibilities from one or another, but if you ask me, I think the value for both parties is immense, because number one, from a management perspective, a storage admin can offload a lot of the overhead that happens on the request for numerous numbers of data stores and LUNs that are needed to serve different purposes. Whereas a vSphere admin can now have the agility and per se, maybe the freedom, as long as it's being provided from the storage admin on a per container basis, to consume it as it needs to be consumed, right? In a sort of controlled but still agile environment, which now you have the ability to get what a lot of our customers that are dealing with our virtualization products, which is agility with control, right? Which in the past we really didn't have that, which is very powerful and important beyond just more than just the technology itself. Josh?
Yeah. I wanted to, before moving on to the next section around VRealize Orchestrator, there was a question about availability of the VASA provider, and this is really actually very important when you start looking at that transition to vVol. So I'm going to go back one slide real quick. When you look at managing your VASA for VMFS, the VASA provider is really just scanning it for information that is reported up by the storage system and providing that up to the virtual center layer, right, which is allowing that virtual center server to take advantage of it for SPBM. When you start looking at vVols, and with the VMFS VASA provider, that can reside anywhere easily, right? You can easily put it on an OVA and deploy it, which is what SolidFire has done in the past, or you could have it on array if that's what your architecture dictates. But its availability has minimal impact, and it's really easy to bring it back online because it's really just a translator. When you transition to VASA v2 and you're looking at vVols, the VASA provider is absolutely critical for the management, implementation, and the lifecycle management of vVols. That VASA provider is doing all of the translation work between the VMware environment and the storage system. So the availability of that is absolutely critical, and I think that's why you'll find that the majority of storage providers, including SolidFire, will be putting the VASA provider as part of the code on the storage system itself to ensure that it has that high availability. Because if your VASA provider is not available, you're not able to provision vVols, you're not able to modify the vVols. That translation has to happen on the VASA provider. So I wanted to address that question that we had in chat before moving on.
Yeah, so let me actually even add a bit just to that too, just before we move on. So to Josh's point, absolutely critical. But and the one thing that's particularly new with virtual volumes and the need for that implementation is if you saw the graphic before that was showing the VASA provider image, notice that the communication that happens between the array and vSphere, it's an out-of-band communication, right? That's why this is so important. So to understand the availability for this solution, obviously one of the ways of implementation, as Josh stated, is obviously having it on the array. But also, even when you have a vendor that delivers their implementation through an appliance, the actual framework itself has the ability, service capabilities within itself that deliver high availability services. And I'm not talking about HA, but within the actual VASA provider, there's an active-active or active-passive sort of mode which the VASA implementation supports, which you can also leverage that, but at the same time you can leverage the HA's ability in the event that the implementation that's being in place is used on an appliance, right? Because depending on what it is, that you may find that those implementations are different, but you are covered. And the big deal here is that it needs to be available because, if there's no communication between these two subsystems, like Josh said, things won't be able to change or be created. But there's one thing to be understood here. If there's something that's already been created and something's already working, they will continue to work. Don't think that if, for example, maybe the VASA appliance goes out or the VASA service on the controller on the array goes out, all your running VMs will stop working. That's not, that won't happen because they're running already. They have their devices and IDs bound, and things will continue to work. So there's high availability built into both of the implementations of the VASA provider for virtual volumes for the different implementations that may exist from the different vendors. So just wanted to make that sort of clear there.
Yeah, and I want to reiterate how abundantly clear that is. The vVols do not stop working. They do not have issues. You just are not able to provision new or necessarily make changes to those vVols if the VASA provider is not communicating properly. Yeah, let's make sure that there's no confusion on that because we don't want anybody crying fire when there's no fire.
Solid fire, baby. Solid fire.
We've kind of run a little bit past where we were anticipating to be, so I'm going to do these small sections really, really fast because I think a lot of people are familiar with it. If you're not, I'm more than happy to follow up with you to go deeper into these two technologies. But we'll start with VRealize Orchestrator. In case you're not familiar with that, it was formerly vCenter Orchestrator. Absolutely free product that is available to you if you have Virtual Center server licensing. And it allows you to, it's a workflow engine, it's a runbook automation tool, and it allows you to really do complex and simple workflows that allow you to go beyond what you can typically script, which means that you can have conditional parameters that allow you to modify the work, the tree of where the workflow goes, half of where it goes, based on the response that it gets with information. It enables broader integrations with things like Puppet and with PowerShell. I've seen some stuff recently around ServiceNow. And so it really extends the capabilities of what you're able to do in a secure virtual environment. And plus, it enables things like people like SolidFire to develop plugins that will allow you to integrate with the infrastructure to elicit changes there, which we do have a plugin under development, and it's something that's being used long-term with what we're doing with VRealize Automation. And I recently saw a blog post on VMware's site talking about the difference between VRealize Orchestrator and VRealize Automation. That was pretty good if you're not very familiar with these two products, and definitely worthwhile checking out on your own time. So when you get an opportunity to look at this later, grab that YouTube link and take a look at it. VRealize Automation, primarily considered a self-service catalog. It has a lot of capabilities. I'm not going to get into them all in the interest of time. But the real key in what we're talking about today is it really provides that end-to-end consumer experience. This is a product that is allowing organizations to enable their consumers to be more self-sufficient and to do more on their own. You manage everything, as you're going to see shortly, with blueprints for deployment. So you can say that, this is the framework. It's almost like deploying templates, but much more involved, not too dissimilar, but more capable than what you've seen previously in things like vCloud Director. And both of these products are available as appliances. They have recent releases, and they have full development kits available. So you can extend what they have out of the box. And so from there, like I said, if you want to go deeper on some of these, check out the link that I provided on the previous slide, and we can sync up later. But I want to keep us moving along, trying to get us back closer on track, because I know there's some other events going on today that people are interested in. Keith?
All right. So just a quick introduction to SolidFire. The purpose of this is not necessarily to be a commercial for SolidFire, but more or less just to give you a heads up on the underpinning technology. The purpose of that is, as you're thinking about automation and what we're trying to convey to you, that in VRealize Automation, as you're exposing specific capabilities through VCO and through some of the vExpert tagging and the things that we've talked about, it's helpful to understand and maybe and then transpose onto other technologies, what are the specific things that can get called out. In this case with SolidFire, we have 5 specific things that stand out in our architecture. We think scale out has a specific advantage. It's not necessarily an exposed capability, because that's not something that you can call out, but it is part of the underlying base foundation of what we think helps you survive generations of code and architecture. The self-healing attributes are things that help us go beyond RAID and beyond some of the back-end legacy architectures to help us not only scale, but also survive not just disk and double disk failures, but node failures, and be highly resilient for the type of service you're trying to provide through something like VCA or VRA. Quality of service is critical. Again, we talked about that a little bit already. Our automation is based on a complete exposed API subset. We'll talk about that as well as inline data reduction. Now, that's something that you can't necessarily select as something that you would turn on or turn off. It's always on, but just like scale out and the self-healing capabilities, those things are just part of the system that helps provide the base foundation. So for those that don't know what SolidFire is, we're a node-based scale-out storage architecture. It's block-based, iSCSI or fiber channel. We won't be getting into the details of that right now, but we scale from 4 nodes out to 100 nodes, which brings us up through about 3.4 petabytes of usable capacity and 7.5 million IOPS. But the net there is that it's not just about how big and how fast you can get, but the fact that you can do it with controls and do it very granularly and provide a bunch of different capabilities. In how that relates to something for VRealize Automation is it provides you a wide range of flexibility for how you build and deploy different policies and capabilities. We've got 4 different node types. I won't get into too much of the details here, but just know that we've got 4 different ways that you can build the nodes going forward. You do have to start with all 4 nodes being of one type and then scale from there. But there is lots of flexibilities about not only these 4 node types, but also previous generations. If you had that, you can add these and not have to worry about generational dissimilarities. And that's part of the advantage of not only scale out, but scale out with shared nothing. That agility is kind of interesting because depending upon if you're in a scenario where you just need to add a little bit of capacity performance, or if you need to add a lot of one or the other, you have flexibility in those node types to be able to scale out, not just to add capacity, but also to be able to have the performance attributes that come with a node to give you some of that, some of those capabilities without sacrificing the performance delivery that you normally have. So I'll skip past this just to know that as we live through the generations of our architecture, one of the key attributes that I think bring us to core conversation is how do we survive any failures in the back-end system. Without getting too deep here, just know that we have a process where we have mirrored objects in the back end that are part of the data placement that we do as part of how we write to the system. And if anything happens in here with a cell, with a disk, with a node, the process of surviving is it reestablishes the A pair, the B pair, and so on and so forth, always persisting what is the most optimal balance of a pair of data objects, in this case 1 meg slices, in the back end of the system as it sits on the nodes. Like I said before, based on time, we won't get too deep into the deep architectures of SolidFire in terms of how we're laying data on the system. If you're interested in those things, contact us and we can go through that offline. But this just gives you a base understanding for how we try to do self-healing high availability without RAID in the SolidFire system as we try to scale. What that helps provide us once we have the scale-out agility and the ability to survive at scale, hardware failures, and any kind of disk failure, is really aiming at what is our real goal here, which is to consolidate different silos of where you traditionally see logos pop up. In other words, sometimes if you're building out a VDI infrastructure, or if you're building out an Oracle environment, those app providers may want or require you to have a separate system, a separate array, a separate set of hardware for those things. And part of it is because they have certain design requirements that they want to fulfill. Our aim in life is to really take care of those silos and consolidate those back into something that's more flexible and dynamic for you to be able to provision and utilize across wide ranges of needs in the architecture. The core for that really is guaranteed QoS. The way this works, again, rate limiting is something that really addresses what we achieve here with a maximum. And just controlling the maximum is just one part of the answer. The criticality here is also delivered in ensuring a min, and then over time we have an ability to be able to burst the I/O up through to what the max burst settings are for that workload if the workload wants it, and if the system has those resources available. And as a result, if we can define and enforce these capabilities, we have a true capability, we have a true way to provide something that you can design for specific application templates and builds, as well as things that should ultimately matter when you try to put something like VRA in place at scale. And in this case, one of the things that we recently got back as a proof point was some information from ESG about what kind of performance problems it eliminates. So ultimately, what ends up delivering when you talk from a VRealize Automation level is something where you could have the consolidation of different types of workloads at different types of levels of performance, and ensuring that all those levels of performance that you're trying to expose and deliver via VRealize Automation, you'll be able to get those. One of the core things to start to wrap up on here is automation. And the way that we really reinforce this is not only having a couple of integration points, but really a base subset that has a full featured API set. So every time you're doing something in a GUI, you can see the matching API sets. This is something that we use and build on for a framework for how we do automation in the future. We're an all-inclusive feature set, so everything that you get comes with it. This is important if, as an example, you want encryption as a core capabilities for a subset that you're trying to deliver. Replication, backup. One of the things that hasn't been talked about yet was implementing SRM into here. And an SRM policy would require that you have snapshot and replication on the array. These are all things that the software just comes with the SolidFire system. And we also have a solution called Agile Infrastructure. This is our converged architecture across multiple configurations. This is where we show how to build and devise architecture and solutions around several platform combinations of SolidFire. And the other cool part here is that we have workload validation proof of mixed workloads consolidating and showing MongoDB, Oracle, and VDI all running at the same time, really conveying what our approach is to the industry. And I'll skip past this for the sake of time and hand it back off to Josh.
All right, I'm going to share my screen here. And we should see the video. And then I will let Rawlinson talk over the demo.
Cool, thanks, Josh. So let's see here. So just before it kind of gets going, just let me kind of set the stage here, Josh. First, pause real quick.
I did.
So here's what we're trying to do here. So obviously, in a way to deliver this new change in the storage infrastructures, in a model where if things were to be sort of consumed from a centralized service catalog approach, think about what we discussed before in the whole concept of agility with control. We now here have an infrastructure backed by full-blown SolidFire arrays, which are each delivering a different set of capabilities and values to different applications, as you see here. What I'm going to demonstrate here was a collaboration that we did between myself, VMware, and Josh and Keith from SolidFire to showcase how this transformation in terms not only from the technology point again, but from an operational management perspective, and how we can speed the adoption of what's coming, of the software-defined storage solutions from SolidFire, what VMware is trying to deliver, that could leverage every sort of storage solution in every platform, which is the powerful thing here. We talked about VASA provider capabilities. We talked about leveraging the control plane and the tags from within vSphere. So we're going to show you here this sort of plugin that I developed by allowing the consumption of storage and the placement of objects based on policies, entirely driven by policy. So Josh, let it rip. In this initial process here, what I'm going to do is that I'm going to choose a MongoDB type of workload. Notice that there are three different disks. Each disk has its own capable policy. So what you see here in the down ramp is different capabilities that adhere to the actual demands of the application itself. And you can see that each one of them has performance standards in a specific characteristic. Each one of those settings and values delivers a different configuration, a different type of performance, a different type of data service on a per object basis. So once we launch that from VRealize, you'll see that now when we go back into the vSphere console, notice that one particular workload, once it's refreshed, notice that the three policies are in compliance, identifying the requirements and the things that are being asked, and they were all sitting on different types of different volumes, right? So that basically the system did the placement automatically on its own. So here, Josh, hit pause real quick. Here, for example, what I'm trying to showcase is, we talk about provisioning initial placement, and that's all fine and great because, the system can actually do that itself. Now, I want it to be perfectly clear that what you're seeing here, what you saw with the different policies being added on a per object basis, is part of the plugin that I built. Something that some of you guys may have heard of on Twitter. We call Project Magic. So what I'm doing now here is that I'm showing typically that from a service catalog consumption, if you want to have that agility and that sort of service level where things are simplified, notice that I didn't really have to map to any particular one. There was no mapping to any volume, right? You basically asked for a particular type of performance value that was assigned and exposed directly as one of the policies, and then the system basically finds the actual placement and puts them where they match. Here, what I'm going to try to do is basically change a request, change a policy. So the things that Josh was speaking to before about how the different values and capabilities can be exposed in different calls, here what I'm showing is, here's that same virtual machine, that same workload with three different types of disks. I'm exposing right now. You can see where the individual disks are currently placed. And what I'm going to try to do now is that I want to change the data service or the performance request or the value for a particular device or the entire set of devices on my virtual machine, right? So there's an action call here called change storage policy.
which will help us deliver what we're trying to achieve. Click play, Josh. Now, if you start thinking about what it takes to do this from an operational standpoint and what we have to do to make these sort of changes, because in the new world now with the different solutions that we have available, changing a policy depending on the array system, the solution that you're using, and what type of virtual volume of virtual data you're using, it may require or it may not require having to move a workload from one data store to another. Well, here I changed the policy on a particular disk, right? And the policy was based on a different type of data service request or value. And if you look at the screen here in vSphere, what happens is that it happened very quickly. But if you look at the disk that I actually changed, and I'm pointing at it there, the policy was Mongo on a particular thing. And now if you look at it, it says standard. But when you look at what really happened is, click pause here. We kind of maybe missed it. But what really happened there was this. There was a change in the request of the data service or the request of the storage attributes for that particular object, and the system automatically migrated the workload object from one data store to another. And if you think about that, that is a very powerful thing, because normally that requires planning. It requires a lot of things that have to be done from a storage management perspective, because we don't always just do these things on the fly like this. Now, keep in mind that for the purpose of this demonstration of how we built this, we did it so that it's effectively on the system. There's a logic within the plugin that what it does is that it looks at compliance. It lets you identify where it's currently sitting. Are the requirements and the services that I'm requesting, are they satisfied where I'm currently sitting? If not, who can, or what device out there can provide it? And then as well as, is there enough capacity and all the different requirements that need to be satisfied before the migration takes place? They're being identified and validated. Once it's done, the system on its own will basically initiate the migration over to where it needs to be so that those requirements can be satisfied. If you think about the impact of that from an operational efficiency and the impact to agility with control, what that delivers, that is exactly that, right? The amount of clicks and things we have to do from an admin perspective, and the people that have to be involved, from a vSphere admin or from a storage admin, depending on the operational model that is followed in a particular infrastructure, there's a lot of steps here, right? So you can see how powerful that becomes. And this is entirely implemented using leveraging SPBM as a management policy framework, but leveraging some of the different things that Josh was able to kind of add to this plugin, which is the tagging approach specifically tailored to the SolidFire capabilities. That is
Josh, if you go back just one quick section, just past the screen to the next part. Yeah, right there. If you notice here, the policy name that he's dropping down has SRM at the end. This is where, to me, one of the coolest parts about all this is really the extent of how you want to define capabilities. And in this case, if you want to add Site Recovery Manager, that requires a subset of other things to add. And as you think about other extensions of capabilities that you want to add, this really gets into the art is in the eye of the beholder and what kind of service policies you want to put together and how complete you want them to be. Is that site protected or not? Is that encrypted or not? And it gets into really business requirements. Sorry.
Yeah, and the key there is that it enables the consumer to have the control to decide when they're ready to have that moved over. Because through the life cycle of a virtual machine, and you're going to see in the next section here in a second, we work under the premise, like, let's say this system is going into hibernation. How does the consumer handle that? So, with this situation, the consumer determined that it was time for them to add protection to the virtual machine or to the disk. And then we'll look at, in just a second, a situation where they're actually going to make the change because they're essentially putting the system in hibernation because, the end of quarter stuff is complete and that system just needs to sit idle until the next end of quarter.
Right. So again, we're mitigating, we're fully sort of abstracting the knowledge of storage at a lower level again, and basically making it so that it's about consuming a data service, a resource, a requirement from a business standpoint, that an application particularly would use. Again, keep in mind that this could be entirely still in collaboration and controlled through two different domains in terms of management, right? There's the vSphere admin, there's a cloud admin here, the cloud architect is controlling and exposing these capabilities here, but the storage admin is who basically almost defines these capabilities at that layer. This, folks, applies, the huge and the big thing, the big takeaway here is this applies with every single supported storage technology that is available with vSphere today. Whether you choose to use DMFS, NFS, or virtual volumes, this is intended to work across everything that is supported within vSphere, but it allows our vendors, our partner ecosystem to take advantage and expose their individual capabilities today without having, if one of your vendors does not have the virtual volumes capability per se because it's still in development, still in work, this delivers not only the way to adopt the new management model that will come with the new storage solutions that are being developed and delivered today, but this allows an infrastructure to move and take I would say, for lack of a better term, the legacy environment that is managed in a different way to bring it to what the new solutions will deliver in terms of operations. Because everything now we're looking at delivering based on policies, and that is a very powerful thing. SolidFire will deliver the VASA provider and the VVol implementation, but you'll also be able to leverage this for the arrays that are non-VASA provided with the integration that Josh has put into this, because you now have that. So think about that power. You don't have to have or manage two different operator models for two different environments that sit within your infrastructure. You are not going to rip and replace everything you have in-house. You will have to manage something the way you managed it before and still deal with the new stuff. So think about being able to bring the old to the new in order to achieve the agility with control that your business demands today, and able to guarantee the service level agreements on a per application basis. It needs the problems with provisioning and management and deployment. That was my goal with this what I wanted to achieve in terms of delivering this plugin. That is where I see a lot of value with the rest of the ecosystem and everybody else.
All right. So from here, we'll talk a little bit about this is to Rawlinson's point, this is something that can be leveraged with any existing storage platform that you have today. It's not wholly specific to SolidFire, right? This is not work that you're necessarily only going to get from SolidFire or from implementing any specific storage provider. In the future, and what you're going to see later this year is going to be some things that will be a little bit more specific to SolidFire in that at present data has to move, and that's time consuming, and that is something that puts additional workload on the infrastructure, puts additional workload on the network, whether it be Fiber Channel or iSCSI or for your protocol, and it takes time. The work that we're doing moving forward is really around taking the stuff that Rawlinson built a foundation on and integrating with the VRealize Orchestrator plugin that I'm developing presently, so that when a consumer makes those changes happen on the SolidFire or on the storage system and are reported back up dynamically through the VASA provider, and the storage policies are aligned appropriately, so that the changes can be implemented. Since SolidFire does everything granular by volume, we can set up replication or modify the QoS profile, and then dynamically update the storage policies and dynamically update the volume that is serving the disk without actually having to move data. So that it's going to be something that I'm really looking forward to sharing with everybody later this year, and I'm highly anticipating it's going to be a lot of fun watching the ability to allow a consumer to change what their profile for their virtual machine is without putting any workload on the infrastructure whatsoever.
Yeah, I think there's a lot of things we could think about in the future as well. If you think about the full extended capabilities of the VMware infrastructure, you think about NSX, you think about even the new introductions of VIO, VDI and DAS. Rollinson, what limitations do we have here? I mean, is this totally wide open to full automation of all parts of the software-defined data center?
Absolutely. So you can expect by VMworld that I will actually add and expand on what I did on this plugin and introduce the NSX piece to it. There will be, extensions to a lot of different things that could obviously do with BIOS we can use. A lot of the things that we have here will work with everything. This was the whole concept of making this work. The initial idea was very focused and minded towards one particular product, but as I kind of took a step back, I was able to see how this would be more powerful and it will have a much better impact on everyone if everyone can actually use it, add their own value to it, and we can continue to evolve it and expand it with the rest of the pillars of the software-defined data center, which is the goal. Everyone wants, again, agility. This is what will sort of help you get agility with control and be able to meet the requirements or the wishes of a company to be able to operate in a certain way.
All right. So, operator, if you could give us time for folks if they would like to post questions. We have a little time for Q&A. We recognize that the Top vBlog results show is going to be kicking off shortly, so we certainly understand that. So if people need to drop here shortly, we totally get it. We got you documented. Part of the gift pack that you'll be receiving for attending as a thank you from SolidFire will include our now, I think, infamous SolidFire socks. In fact, I was wearing them this morning. They're fantastic, as well as the SolidFire and VMware vExpert branded travel case for your cable management, and I'm looking forward to seeing those as well. I think they're going to be pretty excellent. So if anybody has any questions, feel free to put them in the chat, or feel free to speak up once you're unmuted. And one of the questions.
Are you to open all the lines?
Well, let's see. We'll see if anybody has a question, and then we'll just request to have them unmuted so that we don't get a big mess and people scrambling to mute themselves.
Yeah, some questions on the line were specific to the SolidFire system as well. We have some background slides where we can get more specifically into that if you want, or if there's some follow-up, obviously, on VRealize Automation, VCO, any of the stuff around even vVols and whatever topic you want to get into that's related to this webinar. vExperts with no questions.
If you have a question, ladies and gentlemen, please proceed with your question. All lines are open.
Okay.
All right, with that, again, if you want more information, any vector of this briefing, just feel free to ping us back at SolidFire. You've got Josh Atwell and myself, along with SolidFire.com. Josh, your Twitter handle is what?
Josh_Atwell.
And mine is @KeithNorby. The SolidFire one is @SolidFire.
And Rollinson is, go ahead, Rollinson.
@PunchingClouds.
Which is still one of my favorite
Twitter handles,
and that logo is just,
yes.
I thoroughly enjoy that.
Oh, thank you. I try, boys, I try.
Right. Always a good show. Thanks, Rollinson, for your help. Thanks, Josh, for joining us. And again, if you need any other information, hit us on Twitter or go to solidfire.com, and we'll help you from there. Thanks for attending.